Have you ever wondered why organic chemistry is so crucial in our everyday lives? This is not just a question for the academically curious. It's a question that holds the key to understanding the world around us and the life within us. Welcome to the intriguing world of organic chemistry. In the simplest of terms, organic chemistry is the study of carbon compounds and their derivatives. But don't let the simplicity of that definition fool you. This branch of chemistry is a vast and vibrant field, teeming with complex structures, reactions, and processes that shape our world in ways we often take for granted. Imagine for a moment the food you ate today. Did you know that the taste, texture, and nutritional value of that food are all determined by organic compounds? The proteins, carbohydrates, and fats that give us energy and nourishment are all products of organic chemistry. Consider, too, the medicines that heal us and the vaccines that protect us. They are the result of intense research and development in organic chemistry. From the simplest painkiller to the most sophisticated cancer drug, organic chemistry is at the heart of their creation. And let's not forget about the clothes we wear. Whether it's a cotton t-shirt, a wool sweater, or a synthetic fabric, they all owe their existence to organic compounds. The same goes for the plastics that make up our everyday items, the fuels that power our vehicles, and even the DNA that carries our genetic information. In short, organic chemistry is the science of life. It's the science of us. It's everywhere, in everything, and it influences every aspect of our lives. It's a science that's full of surprises, full of discoveries, and full of potential. Now that we've grasped the significance of organic chemistry, let's delve deeper into its fascinating principles and concepts. From the unique properties of carbon, the language of structural formulas, the dynamics of organic reactions, to the far-reaching impact of organic chemistry, we're about to embark on a journey of exploration and understanding. So let's get started. So what makes carbon the superstar of organic chemistry? The answer to that question lies in the unique and remarkable properties of carbon. You see, at the heart of organic chemistry is the ability of carbon atoms to form stable, covalent bonds with each other and with other elements. This ability is largely due to carbon's electron configuration. With 4 valence electrons, carbon is halfway to the 8 electrons it needs to fill its outer energy level. This makes carbon eager to share, borrow, or donate 4 electrons, allowing it to form a variety of bonds with other elements. But it's not just about the number of bonds carbon can form, it's also about the strength and stability of those bonds. Carbon-carbon bonds are exceptionally stable, which means they don't break apart easily. This stability allows carbon to form long chains and rings, creating the backbone for the vast majority of organic compounds. And then there's carbon's ability to form complex structures. When carbon atoms bond together, they can form not only straight chains, but also branched chains and rings. These structures can then combine in countless ways, leading to an astonishing diversity of organic compounds. From the simple methane molecule to the complex DNA structure, it's all thanks to the versatility of carbon. But the wonder of carbon doesn't stop at complexity. Carbon also has the unique ability to form double and triple bonds with other carbon atoms. This opens up a whole new world of possibilities, creating compounds with different properties and reactivities. And let's not forget about carbon's ability to bond with other elements. By forming bonds with elements like hydrogen, oxygen, and nitrogen, carbon creates a vast array of compounds, each with its own unique properties and functions. Carbon, with its bonding versatility, lays the foundation for the endless array of organic compounds we see in the world around us. This is why carbon is, without a doubt, the superstar of organic chemistry. How can we visualize these complex carbon compounds? To answer this question, we delve into the fascinating world of structural formulas in organic chemistry. These formulas are like architectural blueprints of a molecule, providing a detailed plan of how atoms are linked together. The beauty of structural formulas lies in their simplicity and clarity. They offer a straightforward way to represent the three-dimensional structure of a molecule on a two-dimensional surface, like a piece of paper or a computer screen. This provides us with a tangible way to understand the abstract world of molecules. But not all structural formulas are created equal. There are different types, each with their own strengths and nuances. Let's explore a few of them. First, we have the Lewis structures. Named after the American chemist Gilbert N. Lewis, these diagrams show all the valence electrons in a molecule. They provide a clear picture of how atoms share electrons to form bonds, making them essential for understanding chemical reactivity. Next, we have condensed formulas. These are like a shorthand notation for organic molecules. They don't show all the individual bonds, but they do provide a quick overview of the molecule's structure. For instance, the condensed formula for ethanol, a key ingredient in alcoholic beverages, is CH3CH2OH. Finally, we have line angle formulas, also known as skeletal structures. These are the most simplified version. Here, carbon atoms are implied at the vertices and ends of lines, and hydrogen atoms attached to carbon are not shown. It's a minimalist approach that allows us to represent large organic molecules in a compact and easy-to-read way. By understanding and using these structural formulas, we can unlock the secrets of organic chemistry. They are the language we use to communicate the complex structures and behaviors of organic molecules. And just like learning any new language, it takes time and practice. But with patience and persistence, anyone can learn to read and write in this universal chemical language. Understanding structural formulas allows us to visualize and comprehend the intricate world of organic molecules. Now that we've seen the structures, how do these compounds interact with each other? Well, let's dive into the fascinating world of organic reactions, the dynamic transformations that breathe life into organic chemistry. Just as an architect uses blueprints to build structures, chemists utilize organic reactions to construct and modify organic compounds. These reactions are the processes that allow one organic compound to transform into another, bringing about changes in properties and behaviors. Let's start by understanding that organic reactions can be broadly classified into two main types: addition reactions and substitution reactions. In addition reactions, as the name suggests, we are adding something to a molecule. Imagine a molecule as a party, and an addition reaction is like inviting more guests. This leads to a change in the structure and hence the properties of the compound. For instance, adding hydrogen to an alkene in the presence of a catalyst will result in an alkane, a completely different beast with its own unique characteristics. On the other hand, substitution reactions are like a swap meet. Here, one part of a molecule is replaced or substituted by another, again leading to a change in the structure and behavior of the compound. Think of it as swapping out a guest at your party with someone completely different. The atmosphere of the party changes, doesn't it? Similarly, when a hydrogen atom in methane is replaced by a chlorine atom, we get chloromethane, a compound with different properties. Organic reactions are an integral part of organic chemistry, providing the tools to manipulate and modify compounds to suit our needs. They are the driving force behind the creation of countless substances that we use daily, from medicines to plastics and everything in between. So, to sum up, organic reactions are not just about molecules interacting with each other. They are about change, about transformation, about creating something new from the old. They are, in essence, the dynamic transformations that breathe life into organic chemistry. So how does understanding organic chemistry impact us and our world? Imagine a world without medicines, without the variety of fabrics we wear, or the multitude of products we use daily. It's nearly impossible, right? That's the world without organic chemistry. In the field of medicine, organic chemistry plays a vital role. It provides the fundamental understanding needed to develop new drugs and therapies. From the simplest pain reliever to the most complex cancer-fighting drugs, all are fruits of organic chemistry. Next, let's consider agriculture. Organic chemistry helps us understand the nature of soil, the nutrients it contains, and how these nutrients affect plant growth. It has given birth to various fertilizers, pesticides, and growth regulators, ensuring our food supply meets global demand. Then there's the textile industry. From the synthetic fibers in your comfy yoga pants to the dyes that give them vibrant colors, organic chemistry is involved. It has allowed us to develop textiles with desired properties, be it durability, comfort, or aesthetics. And these are just a few examples. Organic chemistry's footprint is everywhere, from the plastic in our everyday items to the fuel that powers our cars. So the next time you pop an aspirin, wear your favorite shirt, or drive your car, remember it's all thanks to organic chemistry. With its countless applications, organic chemistry truly shapes our world in ways we often overlook. Let's recap the journey we've taken today through the realm of organic chemistry. We've explored the vital role of carbon, the backbone of this field, and delved into the language of structural formulas. We've witnessed the dynamic dance of organic reactions and pondered over the profound impact of organic chemistry on our world. This intricate science is more than just a subject, it weaves the tapestry of life itself. Remember, organic chemistry isn't just a subject, it's the chemistry of life. Subscribe for more eye-opening discussions on the fascinating world of science.